Hey everyone, and welcome back. This is BuckeyeCTF 2023, hosted by Ohio State. Overall, pretty fun CTF, a lot of challenges. I think there were like 46 or something like that. In this video, I'm going to be covering 22 of the challenges, so if my voice is a little bit sore at the end, that is why. Otherwise, yeah, it was fun, and let's get started. The first crypto challenge is My First Hash by GeekGeckoAlex. It says, here's your flag, we're given a hash. Psych, it's encrypted, you think I'd give it to you that easily? Definitely don't look at my code though. When you find the flag, put it in the BCTF format. And we're given a download Python file. If we look at the Python file, we're given a hash, we give it some input, it's going to hash the input, and it's going to compare our input hash with the flag hash, and if they're the same, we have the flag. We're not going to be cracking MD5, so we're going to take this and see if it's a known hash. So we can go to crackstation, crackstation. Let's type it in, I'm not a robot, crack, and there we go. We have a result. So the plain text is orchestra. So if you wrap that in a BCTF, that was the flag. The next crypto challenge is rivest-shamir-adleman, so RSA, and it's by JM8. It says big numbers make big security, and we're given a download Python file. In the download Python file, it's specifying a message. It's going to convert that message to an integer. We're given the P and Q, which is interesting. Normally these are private for RSA. And we're given an E. Then it's going to do some textbook RSA. It's even going to calculate D for us. And then it's going to print out the numbers. So we have the public key, we have N, so the modulus, and we have the ciphertext. So to solve this, Copilot will actually solve this for us, or it did when I did it the first time. So we say M is equal to pow. And yeah, it actually does a good chunk of it. M is equal to convert from the long to bytes and then print out the message. So let's see if Copilot solves it. It was dist. And there we go. BCTF, I used your keys, thanks. So easy challenge. Next up is Crypto Secret Code, also by GeekGeckoAlex. It says, here's your flag again. We're given a weird string, LOL, you snub wrestle, good luck trying to undo my XOR key I used on each character of the flag. Cool, so we can copy those over and start playing with them. For me, the hardest part of the challenge was understanding what this encoding is supposed to be. I thought this was supposed to be like the MAC address, where each byte is separated by this little colon. Turns out that's not the case. I actually had to ask for help, and you're supposed to just remove the colon and then treat it like hex. So this is not a byte, this is a byte, which is a little bit strange, but once you know that, the rest of the challenge is simple. You're just going to XOR the two of them together. So to do that, we're just going to delete all of these. I just do that by replace with an empty string, and then convert that string into a byte string. So, this will be the first byte, then this will be the second byte. And then from there, I use pong tools to just XOR this key with the ciphertext, and we should get the flag. It's Python 3, solve.py. Oh, Python 3, not Python 2. And there we go. It says BCTF, don't look up snub wrestling. Next up is Crypto Electronical, also by JM8. It says, I do all my ciphering electronically, and we're given a website. If we go to the website, we can type in a message to encrypt it, we hit submit, and we get back some ciphertext. And there's also source code, which we can look at in the IDE. So in the source code, it's defining a flag in the environment variable. It's constructing an AES object. It's using ECB. This is like the insecure one, electronic codebook. So all the blocks encrypt to the same thing. The same input equals the same output. If we look at the encrypt function, it takes in a message and it's going to pad it with null bytes. So it's doing an ljust with null bytes to 16 bytes. Then here's the route for encrypting. It's going to look for a parameter, and then it's going to encrypt the parameter plus the flag. So somehow we need to abuse this to leak the flag. And the rest shouldn't matter. So in a perfect world, if you do encryption, there should be no way to reverse it. But we're going to abuse some fun stuff with block size to leak the flag character by character. And the way this works is we need to recognize the fact that when it does encrypt, it's going to do encrypt our message, so our input, plus the flag, plus the padding, which is all zeros. And so the block size for AES is 16 bytes. So what that looks like is we're going to have 16 bytes of input, just pretend that's 16 bytes. Then we're going to have 16 bytes of flag, and then maybe an extra character, and then the rest will be all zeros. So pretend these are all 16 bytes. So we have some input, some flag, and then maybe an extra character of flag, and then all zeros. When flag is lined up like this, we have a single unknown character. Actually, we do know this character. It's going to be the close bracket, but we're pretending I mean, we don't know any of the other ones. So we're going to say we have an unknown character plus 15 bytes of zeros. And what's fun is this is going to be encrypted, and we're going to get the same ciphertext length out. So, we're going to get 16 bytes of ciphertext out, but we know what matches to what. So this one matches to this one, this block matches to this block, and this block matches to this block. So we have the block where we have 15 null bytes plus one character of the flag. And so what we're going to do is we're going to change our input to G and that, or unknown character, and then a bunch of null bytes. And what we're going to do is we're going to do this G for every single character. So for A, B, C, D, all the way through. And we're going to see which one of these matches the hash we get for this ciphertext. So when we send this over, it's still going to be flag, and then, G, blah, 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 0, 0, 0, 0. We're going to send this over, and we're going to look at the first 16 bytes of ciphertext, and we're going to see if it equals this ciphertext here. And if it matches, we know we have the correct character. So for the very first one, it's just going to be this closing bracket. But for the next one, instead, we're going to send an extra input character, so an extra T. So this is going to get bumped out. This is going to come over, and we're going to have two unknown characters. Well, we know one of them. It's going to be close bracket, but we're going to have one unknown character, one character we know, and then 14 bytes of null. So, this is obviously going to be a different hash. And what we're going to now do is we're going to start brute forcing character by character here, though. So we're going to send an A, B, C, D, E. We're going to send all of those over, and, we're going to get a ciphertext back, and we're going to look for the ciphertext here that matches this one. And from there, we'll know what the next character is. Maybe it's an E or something like that. I don't remember. And we're just going to do that character by character. And so once we have the next byte of flag, we're going to send it, an extra input, which is going to bump everything over. So we have another unknown character. And we're going to brute force this character. And we just do that character by character, and eventually we get the full flag. So let me start running this in the background, and I'll go over the solve script. And let me delete all this. So the first thing I did is I calculate the starting offset. So I want to know how much input I need to send such that one character of the flag is trailing. It's pretty easy to do. You just keep increasing the input size until the input size jumps by 16 bytes or 32 bytes of hex. So, if it's like always 32 bytes and then it jumps to 48 or something like that, you're on to the next block of ciphertext. So I figure out what the starting offset is for how much input, so that I have one like dangling flag character that I can start brute forcing. I have another function, calculate lookup table, and so this is going to take that base, and it's just going to iterate through every string. It's going to ask for it to be encrypted, and so that I know when I get the ciphertext I'm looking for, I'm just going to look it up in the lookup table, and I know what character it was that's dangling on the end. And that's pretty much all you need. There's one last complication. As the flag gets longer, eventually the flag's going to be like, over 16 characters, let's say. And so if we imagine input, flag, and let's say the flag is 32 characters, something like this, flag, and then a bunch of null bytes. Eventually, we're going to have to start brute forcing. I'm not sure how to say this. Like this block right here. And so what's going to happen is we're going to know all of these characters, and we're just going to be brute forcing this character right here, if that makes sense. And so there might be some G's here. Basically, it makes a lot more sense when you just do it yourself, but basically, normally we just grab the very last block, but eventually you're going to have to start grabbing blocks that are kind of in the middle. Once you hit 16 characters, it just kind of makes sense that you need to do it. So that's the only thing you really change in between is which block you need to grab once you wrap over 16 bytes. So just something to keep in mind. But otherwise, it'll just start brute forcing character by character. And if you do it correctly, you'll get out the flag. And it says, BCTF, I can't believe you found my cookbook. So fun challenge. Next up is Crypto Real Smooth by Rebel Android. It says, I know you're not supposed to leave passwords in plain text, so I encrypted them. The flag is in the format BTCTF and not BCTF due to a typo, and we're given a download zip file. The zip file has two main files. It has this database of encrypted passwords and a Python file for generating that file. So this challenge is based off of the fact that you're not supposed to be encrypting passwords, you're supposed to be hashing them, and this is kind of showing one of the reasons why you should be doing that. So in this, they're going to read a password file, they're going to generate a 32-byte key, a 8-byte nonce, they're going to justify all the passwords to length 18, and then they're going to encrypt them, but the key insight here is they're encrypting all of them with the same key and the same nonce. And they're specifically, in the encryption function, they're using cha-cha-20, and they'll encrypt all of them and then write them out to this database file we have. So this file is a whole bunch of passwords all encrypted with the same cha-cha stream cipher with all the same password and all the same nonce. And so the bug here is cha-cha-20. It's a stream cipher, and it's a XOR cipher. And so using this key and nonce, it's going to generate this key stream, and it's just going to encrypt stuff. And when it encrypts it, it's going to do an XOR with that key stream. So really, we have a giant list of passwords that are all XOR'd with the same key string. So we don't know what this XOR key stream is, but the same XOR key is used on all of these. So we can pretty much just ignore all the cha-cha stuff and think that we have a list of passwords all XOR'd with the same 18-byte thing. And so if we knew what that 18-byte key is, obviously we could just decrypt all the passwords. There's probably a bunch of different clever ways for solving this, and my code is actually pretty messy. I tried a couple of different things, so I don't know if I'm going to really be going over the code too much, but I'll talk about the idea that I used for solving it, but I imagine there's probably a much cleverer way to solve this. Basically, the way I did it is first thing I did is not all the passwords are length 18. And so first I got rid of all these kind of garbage bytes at the end. You can see how they're all matching. That's just because like some of these passwords are like ABC123 or something like that. And then it's just going to XOR it with this stuff, which we don't need. Now that I think about it, that means this is part of the password. I could have just looked for the smallest password and maybe XOR'd it, and that would have given me a whole bunch of bytes, making this challenge way easier. Okay, well, now that I see that, way simpler way to solve it. You could just find the longest key, and it's just XOR'd with null bytes, so that's part of the key. And so then you can look at the end of a bunch of them. Well, ignoring that, I just deleted them. So I went through and I just sorted them, and I deleted all the ends that didn't match. And then from there, I just started finding keys that would produce the most printable characters. Obviously, all the passwords are printable characters, and so I would pick a key that generates a printable character, and I would encrypt all of them, XOR all of the ciphertext with that printable character result key. And I do that for a couple of characters at a time until I started getting passwords that I would recognize. Once you get passwords that you recognize, you can kind of guess the rest of the key because you're just doing XOR. Like if the password starts with like PAS, then you know it's probably password, and then you're going to use that. You just do the XOR, and you can get what the correct key was to generate that password, and just generate larger and larger known plaintext. And eventually you'll find a string called like Cristiano Ronaldo or something like that, which is almost 18 bytes. And once you have here, you can just brute force the last character. But just to kind of clarify what I'm saying is, if you know that some line, like let's say this line is Cristiano Ronaldo, and you know what the ciphertext is, if you XOR the two of those together, you'll get out the key, and then you can use that key to decrypt the rest of the file. And just make sure that that is the right key, because you should recognize other English password-looking phrases. Yeah, once you find the Cristiano Ronaldo one, which is like a very long one, you can use that to figure out what the rest of the key is, and then from there you can decrypt all the passwords. In there, eventually you'll find one line that looks like this, and the password was BuckeyeCTF. We do a little known plaintext, so not too bad. Now that I realize it, I probably should have just kept the ends and used that as the XOR key and decrypted the ends of everything, and then I probably would have found Cristiano Ronaldo very quickly, because I would have had like all of this, and maybe I would have recognized Cristiano Ronaldo, the name, and then this would have been a way easier challenge. But still solved it. It took me quite a few hours to do this though. But yeah, well. The first misc challenge is Needle-in-the-Wifi-Stack by Arc Solstice, and we're given a frames.pcat download file. So we can open that up in Wireshark. If we take a look, it's just a bunch of 802.11 frames with an SSID, and the SSID looks like base 64. And that appears to be pretty much all there is in here. So the challenge is probably just grabbing these SSIDs and base 64 decoding them. And if you don't know SSIDs, these are like your Wi-Fi names. So I did this in Python. I used a tool called PyChark. So we're going to load up that pcat file. To grab specific fields, there's a smart way. The way I do it is I just print out the packet first. So we're going to print it out. Oops. Ignore this for now. I print it out and I look at what layers there are, and we can see this is the first layer, so I grab that out. Specifically, this is a layer that has information we want. If it wasn't so zoomed in, this is a lot easier to do. But eventually you'll see an SSID. Yeah, here's the SSID, and so we know that the information exists within this frame layer. So WLAN MGT. So then I take that, and you can print it out just to double check. So again, we're just printing out the same frame layer. From there, you can do dir on it to see what fields exist on this packet frame. And you'll see that, I think somewhere in there, SSID, oh yeah, WLAN SSID, and then that's the actual field name you want. So we can take that, so WLAN SSID. So now we have that base64. We're just going to call base64 to code on it, call it v for value, and then we're going to see if the string BCTF exists in it, and if it does, we print it out. So Python solve, and there we go. A whole bunch of flags, and the flag is BCTF 2.4G congestion. So fun. Next up is misc replace me by Renee. It says, I knew I shouldn't have gotten a cheap phone, and we're given a download file. So if we look at the download file, it is a Android boot image kernel RAM disk. I don't know much about this stuff, so I did some Googling, and eventually I found a command called a boot image x. And I think this will like unpack it. And so now we have a couple different files, and I think next you can also unpack this initrd image file. So let's move initrd image to initrd.gz. And then we can use gunzip on it. Initrd, again, I just found this from Googling around. And so now we have some initrd file. And then from there, we can use a CPIO sort of unpacker, I guess, unzip on this initrd file. Apt install CPIO. Now let's try it. Cool, so a bunch of stuff was opened up. So now we can see what files were on disk. And if you just kind of poke around, so this is a file browser, we were in Writeup. These are all the files. Eventually you find a file called battery fail. You really just poke around for a bit. Yeah, res image charger. And so on some image called battery fail, you can see the flag here. It says BCTF green robot phone. So next up is misc new management by Vortex. It says there's no visible way to get the flag. We're given a netcat port and a download file. So we can just download to this real quick, or sorry, netcat to this real quick to see what it says. It says, hello, the contract is running at here on the Sepolia testnet. Here's your token ID. Are you ready to receive your flag? Yes or no? So this is a smart contract challenge. If you open up the zip file, you'll find the Solidity file in here. And so we're given a token and somehow we can receive a flag. And we're also given a contract address. So most likely the contract address is for this new management. And somehow we need to use that token to get the flag. If you scroll all the way to the bottom, there's a function called getFlag, and it accepts a flag. Really, I feel like this should be token or something. And it needs the balance of the sender to be over 1,000, and if it is, it'll emit this getFlag event for your token, and usually after you do that, you can hit yes. So the goal of this challenge is to somehow get a balance over 1,000. If you go through the code, eventually you'll find this function called transfer ownership. So normally it's common in contracts to have this owner field of the person who created the contract. But here, anyone can request ownership of the contract. And if you're the owner, you can do a function, this function, increase balance. Increase balance. And so you have to be the owner to use this one. But if you are, you can change the balance of any address plus that amount. And yeah, then you can just give yourself 1,000. So what we're going to be doing is we're going to transfer the ownership to ourselves. Once we're the owner, we're going to increase the balance of ourselves by 1,000. And then we'll call this getFlag function with our token and we'll get the flag. An easy way to do these challenges is with Ethereum, this remix IDE. So you copy the file in here, you compile it. You need to install a extension called MetaMask, which I should already have installed, unless I uninstalled it. No, I still have it. In MetaMask, you need to change. Oh no. Oh, I still got it. Okay, cool. I used a fake password. There's actually a couple different setups. First, you need to find a thing called a faucet to give yourself some of these coins. I found a faucet. I had to like register with it, which was kind of lame, but this is the one I used. You go here, you have to like make an account with them, and then they give you 0.5 of these fake tokens. Anyways, once you have that, you can add it to your account. So this is the account. Make sure you're on this like fake test network, the Sepolia test network. Yeah, you have an address, and I have some of the tokens in there, so I can actually pay the gas fees and stuff. So I have my address. I compiled the code. Then we go over to here, and we can. This IDE allows us to interact with the contracts. We can either launch one in a fake place, or we can use a injected provider, which is our Chrome extension, which is MetaMask. So we're on this fake network. And then we're going to say that this contract exists at the address that was given to us, which is this one. So we're going to like create an interface to interact with that contract here. And so now we can interact with the real contract on the testnet. Cool. So let's copy out our address again because we're going to need it in a second. Copy, and I'm just going to place it down here. So the first thing we need to do is make ourselves the owner. So to do that, we need the transfer, was it transfer owner or owner? Transfer ownership. So we're going to find the transfer ownership, we're going to type in this address, and we're going to click transfer owner. MetaMask is going to make sure that we actually want to do this, and we're going to confirm that we want to, and we can view it on either scan, or we can just wait a second. We get a little green checkbox, so it probably worked. Cool. Then we want to increase our balance. So what we're going to do now that we're the owner, we're going to call that increase balance thing. We're going to increase the balance of ourselves. We want to increase it by 1,000. So we're going to say, yes, I want to do that. We're going to confirm it with our wallet. Let's see if it worked. It's possible someone else could request the ownership in between these two calls, and then we'd have to fight with them for ownership. But no, it has succeeded. We got a little green checkbox, so cool. So now we have 1,000 coins, hopefully, and we can take our token. And now we need to do the token to the get flag function. So we put that here. I think that's all it needs. Yep, just this, get flag with our token. Do I delete that? And let's transact. Confirm it with our wallet. Hopefully it goes green. While it's doing that, I'm going to view the transaction on either scan. We just got the green. What's fun is for some of these challenges, you can go onto these like, I forget what these are called, but you can actually see what other people are doing. So if you don't know how to solve it, you can go and see what other people did with these public contracts, and maybe you can kind of figure out the solution from them. So you can see other people are calling transfer ownership, increase balance, get flag. So an easy way to kind of see what other people are doing and get the flag, or see what, or just know what the solution is. Whoops, too far. Cool. Yeah, so we did everything. So we're ready to receive the flag. Yes. And cool. We get the flag. It says BCTF, who put you in charge. So fun. Next up is misc pong, also by Renee, and there's no description, just an IP address. So for this one, the first thing I did was like some nmap scans, and nothing was open except for SSH. And eventually I pinged the machine, and once you ping the machine, you'll get a bunch of these like warnings. It says wrong total length 148 instead of 84. And so once you kind of figure that out, the rest of the challenge was pretty simple. You just need to know that you're supposed to ping this machine. And from there, you'll find out that it's actually returning extra data. So if we load up ping and we look here, so we're doing a bunch of ICMP requests. Let's click on one of them. So here's the reply. You'll see that normally it just returns what you send it. And I think ping is just going to send like 0, 10, where does it start? 10, 11, 12, 13, 14, 15, 16, blah, 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 all the numbers all the way to like 37. And then here's just a bunch of spaces, which is pretty interesting. And if you keep going down, you'll find just like a bunch of messages. If you look at all the responses, eventually you get some content that makes it look like a ping file. So what's happening is they're like exfiltrating a ping file using these ICMP responses. So pretty fun. So what we need to do is just capture a bunch of these ICMPs, responses, and then split out all the interesting information, the ping file, and then just put all that ping file stuff together and view the image. To do that, I just used Wireshark. You just record. I think it's recording right now. And then you set up ping to go in the background, which is doing right now. I use ping-i.1. This will increase or decrease the wait time to just 0.1 seconds because it takes a couple, maybe like 3,000 or 4,000 pings before you get the full image. Once you get the full image, the response body will be the correct size. So that's kind of how you know you're done. But yeah, you just capture all the ICMP responses, and then you just save that file. We use PyShark again. So PyShark, we capture the output file. We only want the ones with the IP source is equal to the remote host. And then for all of those, you just take the ICMP data. It starts out with valid data. You want the like ping file, which happens after byte 96. If you just print it out, you'll see it. Merge all those together and join up a flag file. And once you do that, you'll have raw.ping, and you'll get this out. Mr. DJ put on the replay with, I think that's Guy Fieri. And it's BCTF, please stop pinging me. One little thing, pings fail every once in a while, and so I had to try it a couple of times. I was trying to like splice together two different things based off of sequence ID, and it wasn't working. Eventually, I think it was like the third or fourth try. Eventually, I got like the bytes that were corrupted were not bytes that mattered too much, and it just worked. So definitely need to try a couple of times. Probably also helps if you're in the US. I guess this is Ohio State, so they're probably using servers near Ohio State. But yeah, pretty fun. Next up is misc ogrechat by mbund. It says the Tor only accessible chatting app for ogres, and we're given a .onion URL and a download zip. This one didn't have too many solves, even though it was a relatively simple challenge. I think it's just because most people probably aren't used to the security boundaries of Tor. But the idea behind this challenge is we need to leak the IP address of the Tor service, which as a server owner, you would hope that would be impossible, but we're a CTF, so we're going to find a bug that allows us to leak this IP address. As part of the challenge, you find out that there are two services running on this box. There's the actual Tor service. It doesn't show how the Tor service is set up, but you just see the service. This is running the chat app. And then there's another web service hosted on port 8080, which is a Python HTTP server, and it's hosting the flag directory, which contains the flag. So if we knew the IP address of this box, we could just go to the flag service and just request the flag. There's nothing, it's just the flag there. So somehow we need to figure out where this box lives. And if you load it up, this is what it looks like. So we're in the Tor browser, we're at that Onion website. It's just a chat app, and you can say hi, and nothing too special. If you go through the code, eventually you'll find a very interesting function, fetch URL data, and this happens when you send a message that has a URL looking like thing, and it's going to try to grab the icon and like some metadata so that you can get that like live preview that you see on like all apps like Facebook and WhatsApp and all that stuff. It kind of like shows a pop-up of what that web page looks like. The problem with this, though, is that the server is going to make a request to a third-party service, and when it does that, the third-party service can just see what the source IP address was. So what we're going to do is we're going to copy a webhook address, and we're going to send this in the app, hit post, and when we do that, the backend server is going to make a request to webhooks, and it's going to leak the IP address. And so now we have the IP address of the backend Tor service. And once we know what this is, we can just go to the URL and we'll get the flag. So BCTF, don't tell the feds my IP address. So fun. The first Pwn challenge is Pwn Beginner Menu by GeekGeckoAlex. It says, I just made this menu for my coding class. I think I covered all the switch cases. We're given a netcat port and some download files. If you look at the download files, basically it's just kind of like a big menu, and it'll ask you for some input, and each of the inputs has different options, but each of the switch cases ends in an exit. So you can see if our like input was a 2, then it'll do this, and then it'll exit. But somehow it covers all the options, almost all the options. But if we can get to the end, so like we supply input that doesn't match one of these cases, it'll print the flag. The solution to this was just to type in a negative number. Again, it's just a beginner challenge. So you type in a beginner number or a negative number, and it won't match any of those conditions, and we get the flag. So BCTF, you are sneaky. Next is Pwn Starter Buffer, also by GeekGeckoAlex. It says, tell me your favorite number, and I might give you the flag, smiley face. We're given a netcat port and some download files. So for this challenge, if we look at the code buffer.c, there is a when condition here that'll print out the flag for us. It's going to initialize this flag variable to some random hex, define a 50-byte buffer, ask us for a number, then it's going to read in, and here's our first bug, it's going to read in OX 50 bytes, which is 80, into a 50-byte buffer. So we have a buffer overflow. Afterwards, it's going to check the contents of flag. If it is equal to all E's, it'll print the flag. So if we're lucky, the stack is aligned such that it goes buffer and then flag. And if that's the case, when we overwrite buffer, we can overwrite the flag variable, and we'll just set it to all E's. So to do this, let's do Python 3. We're just going to generate our payload, so 80 bytes of E. Maybe you could use less. Let's copy over this netcat port. Use that. When it asks us our number, we're just going to send it 80 E's. And there we go, we get the flag. BCTF, why write over my values? Next up in Pwn is some Pig Latin, some more Pig Latin, and it's by Renee, and then we're given a netcat port and a download file. So for this one, if you look at there's this run file that the Docker container is running, and so it's going to run this binary, and it's going to say printf you crashed my program flag if this does not exit successfully. So somehow we need this to crash or not exit successfully because it's an OR condition here. And if we can get it to crash, we get the flag. And it's a Rust program, and so Rust is supposed to be secure and all that stuff. So I guess the idea is like we shouldn't be able to crash a Rust program, but if we can crash this Rust program, we get the flag. The way this works is it's going to call getLine, so it's going to read some input. Once it has input, it's going to then split on white space and convert that input into Pig Latin. And so somehow we have to crash this. I'm not too good at Rust, so I just tried a bunch of random crap. Eventually I found out that doing some Unicode stuff crashed the process. So that's why my solution was If you want to know why, I don't know. You'll have to talk to someone smarter. But it does give us some error is not a character boundary. But whatever, we get the flag. So the flag is more Pig Latin, which I'm not even going to try reading, but fun. The first reversing challenge is Currency by GeekGecko-Alex. It says, need to convert USD to another currency? Well, I hope it's either euros, Canadian, or yen. And we're given a download jar file. So the first thing we can do is decompile the jar file. So let's use procon decompiler, converter.jar. And if we look at the bottom, we'll see the flag right here. BuckeyeCTF, oops, you found me. Next up is 8 Ball by Renee. It says, let me guide you to the flag, and we're given a download file. In the download file, there's a binary called 8 Ball. If we open it up in Ghidra, here's the main function. It's doing a bunch of stuff, some comparisons, some sleeping and thinking, and at the very end it says, why yes, here's your flag, and then there's a function called print flag. And we can see there's a bunch of variables, and it looks like it's going to do a bunch of XORing and some other stuff. And eventually it'll print the flag. But since there's no global variables here and there's no input, we could just call the print flag function and maybe we'll get the flag. So one way to do that is in GDB. So let's just copy out the address of print flag. Let's load it up in GDB 8 Ball. Let's run it. It asked a question, blah, 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 we don't care. So we're going to do jump to that address, OX. And if we look on the stack right here, oh, here it is. BCTF, aw shucks, you're making me blush. And if we scroll up a little bit, I think it does print it. Oh, it hits a seg vault. Maybe the stack is unaligned or something, but we can see here, BCTF, aw shucks, you're making me blush. So fun. The first web challenge is Triple D Columbus by GeekGecko-Alex. It says, hi, I'm Guy Fieri, and we're rolling out looking for America's greatest diners, drive-in, and drives. And we're given just a website. So if we open it up, where there's a little Flavortown USA sort of website, since it's the first web challenge, you can probably just view page source and search for BCTF. And if we do, we see the flag. So it's p hidden BCTF inspect element is pretty cool. So fun. The next web challenge is Spa single page application by mbund. It says, and enjoy a relaxing visit to our spa. There's no download file, just a URL. And just a couple images of spas. So let's view page source. We have a generic SPA. So let's look at the JavaScript. There's not too much to go on. Usually when you use these minimizers and stuff, the real code's at the very bottom. And so this is probably the exciting stuff. If you just look through this, you can see some admin stuff. So maybe we're supposed to go to an admin route. There's also an API call called isAdmin. If we keep looking, eventually we find this base64 string here. I can make it a little bit bigger. Scroll all the way back down. There's some like base64 string here. So we can take this and decode it. Base64 decode. Let's see what's going on. And we get the flag. So maybe the idea was we'd go to like the admin route or something and eventually something would happen. Or maybe we're just supposed to find this base64 string, but we have the flag, BCTF. The ultimate spa is a React spa. So fun. The next web challenge is Stray, also by mbund. Stuck on what to name your stray cat, we're given a URL and a download file. If we open up the download file, it's a little Node.js server. There's some route called cat. It selects a category. If the category is of length 1, it'll read from some names folder. And if we look at the directory listing, there's a names folder with an F and an M in here. And so the F contains a bunch of female names, I'm guessing, and the M contains a bunch of male names. And it'll read one of those and then pick one from random and return that name. But we can see the way that they're doing this like path.resolve. If we could specify an interesting category, maybe we could read other arbitrary files off disk. If we look at the Docker file, we can see it's copying in a flag.txt. So there exists a flag.txt on disk, and so maybe we could read it. There was one little trick though that we need to bypass. It's going to read category from the query string, and the category length has to be equal to 1. So normally this would be like M or F for male or female. But there's a neat little trick with the Node.js query string parser, and you can pass in arrays with rec.query. And so, this console.log wasn't there. But an array of length 1 would be equal to 1. And if we look at Node, if we do a plus, flag.text in the array, when we do a string join on those, or a string addition, I guess, concat, this one will be converted into just a string, and this is what we get. So what we're going to do is just pass an array it's going to have a length of 1 because there's only one element. And when it joins together, we'll be able to do a directory traversal and just read the flag file. To see what this looks like, let's go to the website. So there's 2 links here, generate male cat name, generate female cat name. Let's click on the male. So we can see this is that vulnerable parameter. It's just the letter M. What we're going to do is we're going to cast this into an array. So now M is an array. And now we're going to do %2f. So up a directory and flag.text. And there we go. It says JavaScript is a great language. So fun. The next challenge is Web Text Adventure API, also by mbund. It says explore my kitchen. We're given a URL and a download file. In the URL, you'll see that it's a Flask app, and there's like a bunch of rooms, and you can explore the rooms. Eventually, you'll find a API call here called API load. And if you go through the code, you'll see that it's going to read in pickle files. And as we hopefully all know, that you shouldn't be serializing or deserializing untrusted pickles because it's a pretty easy command injection exploit vector. So that's what we're going to be abusing. We're just going to upload a pickle file, and we're going to put a reverse shell in there, and then we're just going to start exploring the blocks. We don't have to worry about anything else. So to do that, I have this Python code for generating pickles that do command execution. So I just call the function generate payload. So in here, we define a class that has the reduce method. So when this gets deserialized on the remote server, it's going to call OS system with the command we pass it. We wrap that into a payload. We print it out. Now we're going to generate a pickle file, and we're just going to send that over to the remote server to deserialize. So we have the base. I just make sure everything's working. Then I'm going to post to that pickle deserialization web endpoint. We're going to pass a file. The file is named file.pickle. And the payload I'm going to have it execute is just a Python reverse shell. I don't know what else is on the box, but I know from the Docker file, at least Python 3 is there. So this is just some generic Python 3 reverse shell I found on Google. In the callback, I'm using ngrok. So I set up an ngrok. You do ngrok TCP and then a port. So I just said 9999. And I set up a netcat listener also on port 9999. And so when this code executes, it should spawn shell and connect to my local machine. So let's see if that works. Boop, boop, boop. Python 3, solve. And if we look down here, we just got a little $sign, so that means we have a shell. So we can type ls, and in the directory, we can see a flag.text, so cat flag.text, and there we go. BCTF, you found the Python pickle in the kitchen. So this is Web Area 51 by Renee. It says Area 51 RAID Luxury Consulting Services. We're given a URL and a download file. I'm just going to start this in the back because it takes a while. In the code, there's a bunch of different files. Basically, the idea is there's a web service and there's a MongoDB instance. In the MongoDB instance, there's a bunch of users, all of these users, and there's a admin user. The admin user, their session is the flag. The sessions are the cookie sessions. So if you have a cookie value of, like, say, this string, that means you are logged in with this username. So if we knew the session for admin, we would know the flag because the cookie is the flag. There's 2 routes for this web service. There's a login and just a generic get. If we look at the login API, we can see it takes the username and password from the body, and it's going to check to make sure they're both string, and then it's going to do a user.find, so a mongodb.find. And if you can find it, you log in as that person. There's also the default web request, and so if you're logged in, you'll see a special dashboard, and if you're not logged in, you'll see an index. And the way this one works is it's going to grab session from the cookie, and it's going to do a JSON parse in it, and then it's going to pass the token it finds in that session cookie to this MongoDB query. Since they're not doing type checking, this is vulnerable to a MongoDB injection, we can specify arbitrary parameters to this MongoDB query. So normally you would expect token to be like ABC123, but now since we control token and we control the object type, we can instead do something like it must be a regex that matches, start with, whatever we want to fuzz. So maybe it starts with an A, we can check if it starts with a B, if it starts with a C, and it'll match any token that starts with a C. And so therefore we know we've successfully found something. So we're going to use this to brute force stuff. We're going to say match a session that starts with BCTF open A. And so if there is a session that starts with this, then we will see the dashboard. But if there is no session that starts like this, it's going to take us to index. And so we can use that fact to just brute force character by character to see what the first character of the flag is. And so we're just going to do that for every character, and eventually we should just get out the entire flag. So that's what the brute forcer is doing in the background. We can see it's almost got the full flag. Looking at the solve script, pretty simple, just going over what I just said. We're going to start with the flag. While the flag last character isn't the closing character, for every string in printable, print out the flag, and then send over a request using the cookie session and create the JSON object that is token is equal to regex, start with flag plus C. And so like I said, we're just going to brute force every character. If you get it wrong, then the word conspiracy is in there. I'm just going to stop that. If you get it wrong, the word conspiracy is in there. It's just like some word I saw that was in the index and not the dashboard. So if it's not there, you know you got it correctly, and we add it to the flag and we just print it out. So it's all done here. Oops, let me go back up. If for some reason the star doesn't work, I think that's just because it's a regex character, so it matches closing bracket, but it should be a closing bracket. But anyways, this is the flag, BCTF. They're using chemicals to make the fogs gay. I think that's supposed to be frogs, and then closing bracket. So fun little Mongo injection. The next web challenge is Web Infinity by JM8. It says, it's like the popular educational game, but it never ends. We're given a URL. It says, note the flag format for this challenge only is flag. And we're given a download file and that URL. So this challenge is based off of Kahoot. So the idea is like, you know, I think it's used a lot in educational settings, but it'll ask a question and you have to guess the answer. These Kahoot questions are pretty much impossible. Like, what beetle am I thinking of? It'll ask like, what is my favorite number and what is my favorite shape? And if you look at the server code, you'll find out that it's random. So we're not supposed to win this by traditional methods. We have to do something else clever. If we look at the WebSockets, the network, we'll see that they are using WebSockets, which is interesting. So maybe we're going to be doing something with that. But just taking a look, we can see that they're using socket.io. It does like this like weird polling sort of stuff. WebSocket, let's look at messages. We can see that every once in a while it's sending down a game state. We can see it has the correct answer here. It sends the correct answer at the end of a round. So this would be the start of a round. So it's going to send us a scoreboard that has everyone's score, the question index, and the question, and I think also the image. Cool. What's interesting to note is you can join at any point, and your goal is just to get to 21 correct. And when you get to 21 correct, it gives you the flag. So another interesting thing. If we look at the server code, so this is the code. Game state, there's a bunch of code in here that you can read, but this is what happens when you answer something. So when you answer, it's going to check if you've already answered, so we can't just submit all 4 answers, that's out. It's going to add you to this answered list and just make sure you haven't already answered. It's going to make sure, see if you're a new user. If you're a new user, it'll create an entry for you on the scoreboard. If you got the answer correct, it's going to update your score on the scoreboard, and if you have over 21, it'll tell you the flag. And then at the end of the round, after 8 seconds, it'll tell everyone what the final scoreboard was, and if they got it correct, blah, blah, blah. So the bug happens in that they update the scoreboard. There's 2 little things. One is they update the scoreboard immediately. Really, they should be updating the scoreboard at the end of the round. So that's part of the bug. And the other thing is you can join mid-round and see what the current scoreboard is. And so maybe there's multiple solutions, but my solution to this was I created 4 users, and every round I have them guess all of the correct numbers. And then I have a winning user that's automatically just going to take what the winning hand is and always submit the correct one. And then every like 3 or 5 seconds or something like that, I have a new user that joins like in the middle of a question ideally, and they can see what the scoreboard is and they see if the scoreboard has changed. So then I know which socket ID or which player guessed the correct one. So like I said, I'm going to have create a new user every once in a while that's just going to see if the scoreboard has changed. If it has changed, if any of them, the interesting ones have changed, I know which answer was the correct one. I give that to my winning hand, and my winning hand submits the correct one. Cool. So this is kind of what the winning script looks like. I'll just kind of scroll through it. I'm not going to actually cover it, but you can see I'm creating 4 of them. Each one of them just saves its ID. Every time it receives a game state message, it just submits whatever answer it should. This is the winning code. The winning code just doesn't really do anything. It just prints out the score every once in a while just to keep up to date. Then I have the set interval code. This is like a new socket that I create every couple of seconds, every 3 seconds, and it's going to connect it's going to get that game state, and so it gets the most up-to-date leaderboard when you initially join, and it's going to go through and see if the leaderboard is different than the previous leaderboard, and if it is, it's going to see which one guessed the correct answer, and it's going to tell the winner to admit that as the correct answer. So it's not the most reliable code, but it's good enough for CTF, and it works. And so you can see this is like a round. So each one of these is submitting whatever answer they should be. So this is a 3, a 2, a 0, and a 1. The winner is just going to print out its score. You can submit as many times as you want. It just kind of happens that way. Eventually, the new user is going to see that the correct answer is 2 because 2's score on the leaderboard went up. And then winner is going to submit that score or that answer. Eventually, at the very end, you should just get the flag. So we get the flag. It says, please don't kick me from the Kahoot, and then some string or something. So fun. The last web challenge I solved was web certs by mbund. It talks about do we get certificates for the CTF? And so they built a challenge around it. We're given a URL and a download file. This challenge really wasn't too bad. I'm guessing most people just didn't try it because they're working on other web challenges. But basically you can type in a name, what place you got. You can't submit first place. You hit generate, and it'll generate this little certificate. And so we can see BuckeyeCTF 2023, Team Sloppy Joe Pirates. We got second place. We didn't actually get second place. Then you can verify it. If you verify it and you're in first place, and the certificates are also signed, which we'll talk about in a second, it'll tell you the flag. So to see what the server code looks like, this is the verify request. So it's going to read in the PDF. It's going to read through the tokens, which I guess are stored somewhere in the PDF. And from there, it's going to try to verify the JSON web token that's in the PDF. And it's going to use this Jose package, JWT verify token, and it's going to import the public key, and the server is using a public key and a private key to sign, and we have the public key, but we do not have the private key. It's going to try that, and if it doesn't work, maybe it'll throw an exception, and if it throws an exception, and this is where the bug is, it'll try to verify it, but it's going to use the public key as just a token. This is not how you're supposed to be using the public key. So the public key is just going to be treated like a string, like just a secret key. And that's going to be used to verify the certificate. Since we know what the public key is and it's just being used as a token, we can just sign a certificate using this public key. And so it'll fail this check, but it'll succeed this check. And so our certificate will be a valid certificate, no matter whatever we want to craft. And so if we keep going down the verify route, we'll see if we are in first place according to the certificate, it will give us the environment flag. So our goal is to forge a certificate that is in first place with a valid JSON web token, and if that is the case, we get the flag. So really not too bad since we have the JWT key. It's just the public key as a string. And so yeah, to solve this, I just modified the server code. So this is not what it originally looked like. It looked very similar to this, but I just changed it a little bit. So the things I changed, there was like a condition to make sure you're not in first place. I just removed that. And here it was using the private key, but instead I'm just going to use the public key, new text encoder encode public key. And yeah, that was it. Then I just generate a certificate locally. I probably should have started Docker already. I think it's Docker compose up. We'll let that run. So what we're going to do is we're going to generate a certificate locally that matches. They're using the same public key on this local Docker as the remote one. And yeah, that should be it. Hopefully this spins up quickly. Sweet, it's running. I forget. Let's check Docker. Oops. Let's see what port it's running on. 3001. So let's go to localhost 3001. So we just need to create one, SJP, oops, capital P, 1. We can't generate it because it says the value must be greater than or equal to 2. So let's go to inspect element and let's just fix that real quick. So it's just a client-side control. We'll say the minimum is 1. Now we can generate it. Cool, we got certificate 4. Let me just copy that out. And so we can take a look at this. We have a PDF saying we are Team Sloppy Joe Pirates in first place. Cool. So now let's go to the official website. We're going to verify the certificate. So we're on like the certs.chal.pono. We'll load this, open, and please verify, and we did it. So BCTF, at least it wasn't an actual PDF challenge. Very true. So fun challenge. And that is all the challenges I solved. So thanks again to Ohio State for hosting, and I will see you at the next CTF. Cheers.